Right, so we should have our skills test check back. No marks as such, because I just wanted to have a look where people were, see what they're looking at. Quite a few of you were long division crazy. All right, you just wanted to long division for nearly every question. Crazy, man. So I would be using long division as possibly a last resort. When I'm dividing by a quadratic, and when I'm dividing by like 2x, take 1 as an example for 3-part A. So I'd like you to just check some of you, because some of you use synthetic division here. And then when you had your little doodad here, because you would have ended up with the 4x and the 5x plus 21, but when you multiply those together, you would have had 4 times 2, which is then 8x. And that's 8x cubed, which is not what your polynomial should be. So you do need to make sure that you double check when you're timesing through. So with that, when you're doing this 2x take 3, you sort of have to divide through by that factor there. And I can't stand it. I make mistakes. So that's why when it's not just x take 3 or x plus 1, I go the long division. And I also, go long division when it's, well, you have to, when it's a x squared, a quadratic downstairs. So please check a couple of minor errors here and there, which happens. I'll be honest, when I was doing this too, I made a couple of whoopsies. So do double check if it's a test. You want to just, I guess you could check by doing a quick expansion. And does that equal your original polynomial? That's if you have time. I do that, at the end, if you've got time to do it. What was the other thing I wanted to talk about? I normally make notes as I go. Yeah, look, when it says x plus 1 and x take 2 are factors, again, one of the options is that you sub in minus 1 equals 0. So I really want you to write that statement. Okay, even if you use synthetic division here, you would have got that a plus b thing, but make sure that you're saying that that would equal 0. So have a look. As I said, some people, I think, were also trying to use long division for number 2. It's like, So some of these questions should be short, sharp, shiny. So just have a look at alternative methods. For question 4, I was just in the mood. So sort of gave you 2 options here. This is if you're equating coefficients, if you're thinking you like that. If you wanted to use synthetic division, used up probably a lot more space, but that was pretty short, sharp, shiny. You used your calculator then to do your simultaneous. I think with this one, you didn't have to do synthetic. You could have just subbed in. So if x equals 2 is a root, then again, I would want to see p of 2 equals 0. Write down what you are thinking. Okay, it's not just about the final answer. The markers are looking at, if they're going to look at the difference between, is this an A or an A plus? Are they looking at giving a merit or just staying as an A plus? They're going to go and moderate and look at your work. So you need to make sure everything is nice and neat. Because I'll go, oh yeah, that's how, Bobby writes his stuff. I know Bobby. They're not going to know you. Okay. So yes, have a look. And for those who are just coming in a little bit later, question 8, I have bamboozled myself because I somehow got the right answer, but I made a whoopsie here. And as I said, I think that's probably because B ended up being a nice number. But if you notice, did my sum and product, that was good. And then I put this, but if you notice, if I times 9 by 9 over B, I don't actually get B. That should have been B over 9. So somehow I fluked it. Yeah, I know, but so I'll probably go back and have a look at that and see if I can fix it. A lot of people who did the equating coefficients with this put a D there, and so that worked really well too. Moses, you did the right thing and put B over 9, but I couldn't find the error, so I'll leave that. I'll leave that for you to suss. But do have a look. I was really impressed that people generally were choosing good options and got the right answer, but just have a look and sometimes look at the alternative if yours was all-consuming. All right? So pop them aside, whatever. You can look at that. This is on Daymap, the skills checks the answers, so you can look at that tonight and ask me probably next lesson or the double, any issues that you might have. Okay? All right. So when we've got fractions, okay, if I've got f of x over g of x, right, when your denominator, when that is equal to 0, that's when we're going to have vertical asymptotes. Now, will we always have vertical asymptotes? If it's linear, will we always have a vertical asymptote? Yes, right? For linear, absolutely. If it's a quadratic, will we always have vertical asymptotes? No, it's not an always, because you could have up to 2 if it factorizes or it solves for 2 real solutions. You could have 2. If the quadratic, the denominator was a perfect square, then we'd just have 1. If it has no real zeros, they're only imaginary, then it would have none. What about if we solve the top row equals 0? What does that give us? The numerator, we're solving that. Equals 0. No, not horizontal. Top line equals 0. If your numerator is 0, what's 0 divided by anything? 0. So that's going to give you the x-intercept. Okay? So when that equals 0, you're actually finding your x-intercepts. So things that we sort of know, but we forget a little bit. Yes, you can have horizontal asymptotes. You can also have, do I have to write that? Horizontal? I am now, for those at home. Appreciate that. You can have horizontal asymptotes. And of course, we can have, groovy little word, what's it called? Oblique asymptotes. And that's when they are basically diagonal. Okay? And to get those, when does the oblique occur? Big divided by small. So if we've got quad over linear, we're going to have an oblique asymptote because a linear goes into a quad linear times. Does that make sense? Right? And of course, we can also have a cubic over a quad. Okay? Because again, a quad times a linear gives you the cubic. When we had the horizontal, if you had linear over linear, right, your horizontal asymptote is A on C, right? Y equals A on C. And it's the same thing if you had quad on quad. I'm not saying if we had, because we haven't done these yet, but we will. So if I had ax squared plus bx plus c all over, what comes after c? D. dx squared plus la 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 la. Then your horizontal asymptote will be y equals a on d. They're pretty easy to find. However, to write them nicely, they're going to ask you to do division to find those beautifully, okay? And what's the other situation with horizontal asymptotes? Right, if it's small over big, so as an example, if I've got linear on quad, if I've got quad on cubic, and I guess if I've got linear on cubic, if I've also got a constant over linear, all of these, what would be my horizontal asymptote? Y equals 0. Now you're writing you don't have to write all of this down if you don't want to, because there is a nice summary for you, but that's a bit messy. But we're working our way through, and you're going to that. Now, Moses, my friend. So it's sort of summarized. I guess I didn't, because we discussed it a little bit, I think, unless I discussed it in my mind. So I do that sometimes. But we talked about when it's the same on same, it's those coefficients there, and I didn't have room to pop it on there. But, you know, if you wanted to, then you could. So what are we doing? We're looking at we started with looking at the reciprocal functions, so 1 over, and it's just going to keep graduating until we get to looking at a cubic over a quadratic and graphing it. Your calculators are going to be really useful here. So how did we go when I asked you, if we open that up again, and yes, I know I put 5 instead of 3. Thank you. I hope you realized. Who didn't realize? So 3B, question 1, question 2. Ooh, getting a bit carried away. I thought it was, maybe it was 3C. Oh, wrote it wrong. Should have been 3C. Anyway. I know. How sad. So, 3C, we had a look. Did we get to have a look? Should be pretty groovy. And if you didn't, don't worry, we'll go on and have another little look-see in a moment. But can I ask you to remember, what about question 2? Prove that is a self-inverse. Do we remember? What is it to be a self-inverse? Mac. The same both ways. Okay, so I would be saying you would need to add this to your notes, because a self-inverse is when f of x equals x, and that equals f of f of. So, you know, that's a good question, because it's getting you to look at inverses, and it's also getting you to look at function composition. Keep in mind, your exam, 2 hours, not 3, 2, on 6 different topics. So if they can combine concepts, that's going to be really handy. So this is a self-inverse, and we should have come across that in previous questions. So do we want to do this? So in a moment when I'm quiet, you will do it. And yes, I heard that. She's never quiet. I will be. Because we're just going to now repeat, and you're going to practice graphing and sketching some rational functions. Okay? All right. We good? Righty-ho. Let's have a look-see. I think, shall we do these on the same set of axes? Oh, yeah, why not? So let's have a look at 3D. And yes, I skipped a little bit of stuff there because you're going to see it's actually quite nice. Yes. They don't cancel out. But take -3, the absolute value of -3 is 3. And what's the absolute value of 3? It's still 3. Okay, so this is where I would expect us to be. We look at this sort of function here and we go, yep, not a problem if I wanted to graph this. So no need to graph. So you could do this on your graphics calculator easily. I would like to think that you could also do this on your piece of paper equally as easily without even going to your graphic. Okay, so we're going to start with our friend here. Y equals x plus 3. 1, you know it's linear, correct? And the easiest way to graph a linear function is to just get two values. I would say your x and your y-intercepts in this case. Yeah? So you can see here, what's my y-intercept? 3. Okay, and my x-intercept is -3 because what makes that whole thing equal to 0? So remember, in your mind, you're going x-intercept, y equals 0. And this is going to work for every function that we do. This is what you did in year 8, it's what you did in year 9, it's what you did in year 10. So look at what I nearly did. Right, we get -3. And by the way, if I was messing around, I did this and I accidentally connected, why would I know that's wrong? We're looking, that's right. We've got x is positive, which means it's a positive slope, it's increasing. So here we go. Simples, oops, make it better than mine. All right, to do your rational ones, the first thing you should do is look at your denominator. It's linear. So what do we know? Its vertical asymptote is? X equals -3. Now, bugbear of mine, when you're writing this down, don't just write -3. It's x equals -3. Why is that important? Because we're going to have horizontal asymptotes too. So if you just put -3, how do I know that's your horizontal or your vertical? So x equals, we know. So the first thing we do is we put the dotted line. Do I have a horizontal or an oblique asymptote here?
You don't have oblique, so you do have a horizontal.
So Bobby's saying I don't have oblique, I do have a horizontal. Why do I know it's a horizontal? Right, it's little over big, and so? Y equals 0. Excellent. It's a bit hard when you're using pencil and you've drawn your x-axis in pencil, but there you go. Okay, and this is when, if you wanted to, you could use your calculator to see where the arcs go. I can't be stuffed turning it on. I just go, what's my y-intercept here? 1/3. So I know it has to arc like that. So it's going to go beautiful, right? Huh? I'm getting criticised. Now, here's another little tidbit. You might, your calculator goes normally, your normal scale is between 10 and -10. Imagine you did this on your calculator and your screen did this, right? Can you not do that? Can you make it nice and even so that it is, right? And so I should technically make that out a little bit more, okay? Don't go, oh, lots of space here, and then you do a little schmidgen, or it's just a corner bit I get sometimes, just because the calculator screen says so. Don't do. Yes, question? Yeah, so try, I'm going really quickly here, so do you get points taken off if I start going like this? Absolutely. You know that it's approaching the asymptote. So try and be a little bit careful, and of course, don't cut that asymptote unless it's a certain type of function, which you'll see later, and your calculator will tell you that. All right? No, no, no. So with that in mind, I think we can draw any sort of rational function that comes our way. So this is the one that we're now going to write down. So bit of a heading, rational functions. So we've got a heading, rational functions. "22nd. Okay. So question would probably be, state your asymptotes, state your intercepts, sketch the graph. Okay. If you wanted to, you could even pop that in your calculator now and have a look at it, but you'll see that your calculator doesn't necessarily draw your asymptotes in. Okay. Those playing at home, I have opened the document on DayMap, and I've just gone randomly. We chose to do a cubic, we didn't. We chose to do cubic over quad, sorry. I've gone quadratic over linear, bad luck. All right, so here we go. First step, they would probably ask you to show that it looks like that. It's given you a bit of a clue, by division. So how could we do that by division? Right, we hit our synthetic division. All right, and from some of you, my God, you love your division, so you could do that, no worries. So what am I going to pop? Excellent, we're going to go -3. 1, 2, -1, and I'll just stop. You know what you're meant to get. You go ahead. So again, you're thinking exams and tests, maybe they wouldn't give you this. They would just say, express this in the form ax plus b plus r, or you've seen it in the books. What do they do? Q of x plus the remainder, whatever, right? Different ways, might not say do it, but think about, as you're doing every question in your textbook, think about the different ways that you could be asked to do that same question. Okay, here we go. Oops. So again, you've got your calculators to assist you a little bit, but the first thing we're looking at is we're going to pop in any of our asymptotes, because once you've got those, everything else just flows. Would you agree? We go x, we go y. What should we be asking ourselves? Are there any vertical asymptotes? So are there any vertical asymptotes? Roy, visitor in our class, do we have a vertical asymptote? So in our minds, we're going, how do I know if I've got a vertical asymptote? Where am I looking? Denominator. So is there a value for x that makes the denominator equal 0? So straight away, we know we've got a vertical asymptote of y equals -3. X, did I just say y equals -3? I did. X equals -3. And then we're going, right, what's my other asymptote, if there is one? It's clearly not horizontal because it's big over small, and that's the whole reason that we have put it in this form, because this is your oblique asymptote there. So we will say oblique, and we're not just going to put x take y, we're writing y equals x take, I said it again, 1. Y is on my brain this morning. It seems to be my favourite letter. So far so good? And now sketch that asymptote. Now I've been a little bit shonky because I didn't stick with my beautiful axes. So I better go back and do that. It just helps if you use the squares, I would say. 1, 2, 3. One, two, three. Okay. You've got -1 as your y-intercept. You've got 1 as your doodad, so 1, 1, 1. Can just and look, you probably all know it anyway, but you know you can graph those on your calculator. So how do I put in x equals -3? Well, it's y equals, so we go type, and you don't have to do this, it's just if you wanted to check, but you go type, and you can now see it's x. So you go x, and now you can see, oh my God, they all changed to x. That's all right. We put the -3, go back over, and this is what I do just when I'm, bored. Tool, style, and I can change it to ... So I know that that is my asymptote. You might go, I'm going to know it's my asymptote. I don't need to change the style. All right, exit. We go down here. Uh-oh, it's x. Type y equals, and you can see you've still got your x there, but now we've got the y. X, take 1. You want to put the change, just messing around. Oops, looking good. And then we can pop our function in, and I don't care which one you put in. You can put this, you can put that. X plus x squared plus 2x take 1. That's probably the one I'm going to remember. X squared plus 2x take 1. I said I was going to remember, and I nearly lost it. X plus 3, yes. X plus 3, because there's -3 is the. Okay, so I can now go, and let's face facts, I would have probably done this before I've drawn my axes up, because then I know, I shouldn't just make it even. My axes will now make sure that I go a little bit more this way and a little bit more that way, right? So this, if I hadn't changed, this would be a dodgy graph, and I would probably take off, right? If you do this, I will take off marks. Right? That's not good. You have to make it sort of even. It doesn't have to be, exactly even, but at least you're not having just that little corner bit. Does that make sense? Oh, Dan. You can all imagine what we're saying. Oh, Dan, I can't even see it. I'm just messing with you. So I would say to you, you are now just practicing your sketching. And that's one of the things Mr. Sutton and I agree on, is that even when you sketch in methods, your sketches are a little bit on the dodge side. So you want to make sure that you're taking the time to practice. What would you say is also missing from my graph? Yeah, I mean, with a sketch, it doesn't have to be to scale. Right, I should, points of information, like relevant points, and that's probably then not very good, but anyway, you should always put axes intercepts if they exist. Do you have to calculate them and put them in exact form? Depends if the question asks you or not. But again, you've got your calculator. G-solve, baby. G-solve, yep. Oh, thank you. Yes, I should have absolutely labelled y equals x take 1. So I would imagine this is under a whole thing, and you've got the graph equation there, but you absolutely must label your asymptotes. Thank you, Dan. He's recovered from, Dan. So what are you going to do? You know what? You've got some options. 3D, you want to just get used to graphing some of these things, right? Square root of x, that's a function that we should be familiar with. Some of you might not be. Put it on your graphics calculator and have a look. Okay? So all of this stuff here, linear on linear, you can go through. They've got some nice examples there. Maybe it was 3E I asked you to do. Who knows? You've got that. In here, as I said, you've also got some examples that you want to have a look at and make sure that you have covered one of each. Do you have to do all of the little bits and pieces? No. But I would say, like I just did, take the example, and then you've got all the work solutions that you can see, and you can see the graph clearly. You do not have to do the calculus. No, Nanette. No calculus. That is just all using your graphic. You know, practice, I like the whole use your division. So does that make sense? The rest of the lesson, homework, you want to make sure that we check off the rational stuff. We've got one last thing, the modulus functions to look at graphically, which I think we'll be able to knock off on Wednesday. Friday, consolidate stuff. And I'd be looking at where test is Friday week. So we just had a question about the discussion. There's a little bit of debate about, if you read the outline, it says you need to know the behavior near the asymptotes. Now, it could be that you just need to make sure you've graphed it nicely. But if it does say discuss, that's also quite nice. So if we say discuss, here we go. So the first thing I would also always look at is you're looking at what happens. So as x is getting bigger and bigger and bigger, in other words, it's approaching infinity. So you just move your finger or your pen, you're going, what's happening as the graph is going more and more this way? Do you agree? So as x, the value for x is getting bigger and bigger, what's the value for y doing? And if you look at the graph, yes, it's getting bigger, but in this case, because you're, you can't see that at home, but because your asymptote isn't horizontal, how would you describe it to someone that you were saying, graph this over the phone, right? You were saying, what should you do with this in relation to that asymptote? Well, if they say going to infinity, you might go like that. But it's not going up to infinity, is it? It's actually getting closer and closer to this asymptote. So when we have an oblique, that's what we'll say. We'll say that as x is getting bigger and bigger and bigger, y, or f of x, is actually approaching this asymptote. Would you agree? And if you wanted to, it's from above. You can go, so you can plus or minus or above. I think I used plus and minus last lesson, so now I'm just mixing it up and going above. You can go either. You read it, you should understand. You write it, you should understand. Right? So as, now we go, x is approaching negative infinity. What's happening here, as it's approaching, as x is getting bigger and bigger and bigger this way? What's happening? Right. So y is, again, the function is getting closer to its asymptote, oblique, from below. Does that make sense? So you always cover positive infinity, negative infinity. Now we look at if there's a vertical asymptote, what's it doing near that? So it can approach the vertical asymptote. It can obviously approach it from the right or from the left. Does that make sense? So how do we write that? As x is approaching my vertical asymptote, so as x is approaching minus 3 from the right, what's happening to the y value in this case? Now, because it is not y equals there, it is actually going to infinity. And as x is approaching minus 3 from the left, coming this way, what's happening to the y values? That's it. And it'll be the same. Just look at the graph and describe it.